Hi folks, welcome back. If you have built AI agents, you're probably familiar with all the challenges that go into benchmarking and evaluating AI agents. And today I want to take a look at a couple of papers that talk about the evolution of the techniques that are used to do those evaluations. I want to look at two papers. The first one introduces this new technique called agent as a judge, and the second one is a survey paper that talks about the overall arc of how all these techniques evolved. So let's start with the survey paper because it'll set up a good context for us to look at the other more detailed paper. Now, obviously, if you have built an AI system, one that is making a bunch of LLM calls, human evals are the gold standard, or at least that's what everyone thinks. If you've actually spent time running human evals, setting them up, looking at the data that comes out of this, I've written about this a little bit on my blog. It's highly non-trivial to actually get good signal out of it, especially for non-trivial conversational tasks. The disagreement rate among human evaluators tends to be fairly high, and you have to know how to get the right signal out of it. So yes, they are the gold standard, but they're not very easy to work with, apart from the fact that they're very costly and time consuming. So, of course, by now the field as a whole is very familiar with using LLMs as a judge, which is kind of a natural second step where instead of using humans, you prompt an LLM to rate or evaluate the output of an AI system. And this works decently well. A lot of studies have shown that the agreement rate between LLMs and human evals tends to be pretty high. But LLM as a judge also has its pitfalls that you have to be aware of. The biases of the judge model can often seep into the evaluations. But the more fundamental issue is that LLM as a judge only looks at your final output. That is the core issue. It is not a great fit for evaluating agents that perform multiple steps of planning and reasoning and execution before they give you a final output. If you look at a lot of typical AI agents today, they will write code, they will browse the web, they will do a lot of reasoning and planning over many, many steps. And if you simply look at LLM as a judge and look at the properties of the final output, you will have ignored all the steps in between and how they performed and if something went wrong during those steps. So that's the crucial mismatch between using LLM as a judge for the complex agentic systems that we're building today. That's what this new paradigm of using agents as a judge is trying to fix. It's an extension of the concept of using LLMs as a judge, but the judge itself is an agentic system in that it has many components. It's looking at all the intermediate steps and the intermediate work output of the original AI agent that you're trying to evaluate. So it's looking at the tool use, the memory, the multi-step reasoning. It's looking at the internals of the agent, not just the final output. And now let's switch over to the other paper that introduced this concept and look at some of the details of how this works. The first thing you have to look at is what kind of benchmark task they are performing this whole thing on, both the agent as well as agent as a judge. So for the purposes of this paper, they created a new benchmark data set called DevAI, which is about 55 tasks, all focused on ML and AI. So they're trying to look at AI engineering kinds of tasks. This is an example. This is an image generation task. You're asked to generate images according to specific requirement. So you have an input query, but more importantly, you have a list of requirements. Ensure the generated images are of this resolution, etc., etc. They must have the text feature in them and so on. And then some preferences that are optional, nice to haves in the output. So this is the format of the input tasks in the DevAI dataset. As for the actual agents that are asked to solve these problems, they have used 3 existing AI and coding agents. And just to set a baseline, they've used humans as judges to get judgments on the output of these 3 agents. Like I was mentioning earlier, the disagreement rate goes up as high as 30 to 40%, which is pretty typical of human evals. All right, so here's how they design their agent as a judge. The judge itself is a pretty complex agent and it has all these components. Just like any other AI agent, it has a planning component, it has a memory component, and it has all these different steps which look at the sequence of steps, the intermediate work outputs, and so on of the original agent that was performing this task. So the agent as a judge itself is a fairly complex agent. But overall, it seemed to work pretty well. If you look at judge shift, which is the measure of how much the judgment deviates from the baseline human evaluators, agent as a judge gets pretty low, under 1% on some tasks, while LLM as a judge has a judge shift of 30%. And of course, the cost and time taken by this agent as a judge system is a tiny fraction of what they paid the human evaluators and how long those human evaluators took to come back with their evals. So overall, they've demonstrated that agent as a judge has some compelling advantages over human evals, but more importantly, over just using LLMs as a judge, non-agentic, simple LLMs as a judge. Now, one thing that can be really powerful with agent as a judge, which they did not actually explore in this paper, is the setup where you run the agent as a judge in parallel with your actual agent and where it provides feedback as that agent is doing its job. So you can identify and fix issues at runtime rather than after the fact. So you can almost view this agent as a judge as a parallel watcher slash verifier slash correction agent that is running with the main agent. So that really has the potential to have a big impact on the efficacy of the original agent. Now, whether you'd structure it as a completely different agent or do something different is an open question, but this is something that has a lot of potential for improving how agents work. All right, so that was just a quick look at how agent eval techniques have gone past the initial LLM as a judge, and evals themselves are now becoming agentic. It's becoming more and more complex. Hope you found that helpful, and I will see you next time. Thanks.